Good afternoon and welcome to this demonstration where I'll be demonstrating laser Doppler, tissue oxygenation and pressure cuff provocation to test post-occlusive reactive hyperemia. To do this we'll be using these blood flow devices and the more VMS PC software. So now I'm going to show you the different monitoring systems we're going to use to take the measurement today. Starting from the top, we have the pressure cuff control unit, which pumps up the pressure cuff and displays the pressure within the pressure cuff itself, displayed it in millimeters of mercury. The second system or unit we have today is the high power laser Doppler blood flow monitoring system. We have the flux reading here, which displays the level of blood flow being measured from the fingertip, and the DC, which reflects the level of reflected light being received by the probe. Third system we have here is a dual channel standard power laser Doppler monitoring system, which again records the flux, which is a measure of the blood flow within the fingertip, and again the DC, which distinguishes or illustrates the level of reflected light. Also on the standard power system we have a temperature measurement, which is recording the skin temperature during the measurement. And finally we have the oxygenation unit, which records the SO2, so the percentage of oxygenated blood within the sample, and the total hemoglobin within the sample area also. This monitor also has the capability to record temperature as well. So to start, we'll open up the software to which the devices are attached. To make sure the devices are attached, we can go to the monitor setup icon and make a single click onto this, and it brings up the monitor setup window showing the devices which are attached. This includes a standard power laser Doppler system, a high power laser Doppler system, a pressure cuff control unit, and a tissue oxygenation system. The window demonstrates that all devices are attached effectively, so we'll click OK and move on to the display setup. In the display setup we want to make sure that we have the laser Doppler blood flow on channel 1, and then on channel 2 we'll have the high power laser Doppler blood flow, which measures deeper into the microvasculature. The third channel we will output the tissue oxygenation data, and the fourth channel will have the pressure cuff pressure outputs in millimeters of mercury. So now they're all selected, we'll click OK to confirm the parameters which we'll be displaying. Next we go to the protocol setup. We'll be running a post-occlusive reactive hyperemia protocol, which will give us an indication of the state of the endothelium and the health of the vasculature. So we single click onto the protocol setup, we go to factory protocols, and then down to PORH, which stands for post-occlusive reactive hyperemia. So we click onto the post-occlusive reactive hyperemia tab, and it brings up the settings for this particular test. So we're going to have a pre-inflation period of 30 seconds. That's a pre-inflation period of 30 seconds. Followed by inflation of the pressure cuff to 180 millimeters mercury. The pressure cuff will be held at the 180 millimeters mercury for 120 seconds, so 2 minutes. After this 2 minute occlusion, there will be deflation of the pressure cuff. This will happen instantaneously, and then we'll have a post-deflation period of 240 seconds or 4 minutes. So we'll save this setup and click OK. Now we have the protocol set up. We go to the new icon, which will bring up the screen with which we'll record the trace and the data. So now we have the screen here ready to make the measurement. We'll attach the probes and the pressure cuff. So to attach the probes, we use these probe holders here. They're white, rubberized probe holders, perfect for adhering to the fingertip, as you can see. The probe head fits into the probe holder like so, just pushes in gently. And we'll attach the probe head and the probe holder onto the fingertip of our willing volunteer here. So we attach the adhesive disc onto the probe holder, remove the back of that, and then apply it to the finger. Press and hold it for a couple of seconds to make sure that the probe holder is attached firmly and the probe's not going to come away from the skin during the measurement. We do the same with the standard blood flow and tissue oxygenation probe as well. This probe is for the high power blood flow measurement, and this is for the standard power blood flow measurement and the oxygenation measurement. So again, we take one of these adhesive discs, apply it to the probe tip, remove the backing paper, and once again attach to one of the digits, like so. Next, we're going to put the pressure cuff around the arm of the subject. So we take the pressure cuff, wrap it around the arm, making sure that it's firm around the arm but not too tight as to reduce the blood flow down the arm. So now we've got the two probes attached and the pressure cuff attached onto the arm, and the subject is nice and still to avoid any movement artifact. We can start the measurement and the PORH test. To start the test, we click on the Start Protocol icon. When clicking the Start Protocol icon, a window appears requesting the protocol selection. We're going to select the post-occlusive reactive hyperemia protocol from the drop-down menu, and then click OK. It's now reminded me to, or instructed me to turn the laser on, the high power units. So the laser is now on high power laser Doppler unit, and click yes. And now the protocol will begin. The window which has appeared here has a guideline of the protocol which is going to be run, and you can see clearly here the standard power laser Doppler trace and the high power laser Doppler trace, together with the tissue oxygenation and the pressure cuff pressure. In a minute, now that the sound is alarmed, the pressure cuff inflates to 180 millimeters mercury as defined within the protocol. You can see the pressure cuff trace increasing to 180 and the blood flow signals reducing down to almost zero because of the occlusion which has occurred. The tissue oxygenation reading is also affected due to the inflation of the pressure cuff. After this 2-minute hold period, the pressure cuff will deflate and you'll see the return of the blood flow. During each part of the protocol, automatic markers are put in to aid automatic analysis of the data. So there's the pressure cuff deflating. You can see the pressure trace with the pressure decrease and the increase in blood flow accordingly. We now carry on the measurement for another 4 minutes while the hyperemic effect returns to baseline. Now I will compress the data so you can see the whole trace on one screen. You do this by going to the compress icon on the toolbar. So we click the compress icon until we can see the whole of the trace, and we move the time bar along the bottom of the trace so you can see the whole test from beginning to end. Looks like we're going to have to compress it once more so that we can see the whole trace. So at the beginning here we have the baseline period, which is relatively stable, and then we have the occlusive period where the pressure cuff inflates and the blood flow falls. We have the point at which the pressure cuff is and the blood flow returns. You can see the hyperemic response and a clearly defined return to the baseline level. We have another just over a minute of the trace to go, and then we'll analyse the data. So the final marker being put in here, and the save screen appearing signifies the end of the post-occlusive reactive hyperemia test. So now we're going to save the data. Save here. So this is the reactive hyperemia data in its entirety. You can see at the beginning here we have the baseline data, and where this marker inserts here we have the pressure cuff inflating and the blood flow falling. Here we have the occlusion period, which was 2 minutes in this particular case, and after 2 minutes the pressure cuff deflates and the blood flow and the tissue oxygenation returns. We get a hyperemic response and then a subsequent return to baseline. We can analyse this data using the automated analysis feature within the software. We'll analyse this previous trace we acquired by clicking on this alternative tab here. So we take a single click onto this alternative tab and you can see the data we previously acquired. To analyse this data automatically, we go to the analysis menu item and then down to the PORH analysis feature. Single click on there and it draws up the analysed reactive hyperemia data. This analysed reactive hyperemia data can be saved as a patient report by clicking on the report button and then preview. Previewing a report will load up a 4-page patient report detailing the patient information, the recording information including the monitors used and any comments made which are relevant to the patient and to the measurement. We can scroll through to the analysed reactive hyperemia data with all the parameters which need to be recorded, and an explanation of what those parameters mean with regards to the baseline, the occlusive state, the maximal hyperemic response, the time to maximum, and the area under curve for the return to the baseline level. Once you've captured all this data within a report, you can export the data to Excel, to a PDF document, or to a Word document, which we'll do right now. So we'll just click to export. We'll save this data as PDF because that's how we require to save it this time, and then save the report.pdf to the data folder we have already set up. I'm now going to close the report window and close the analysis. As well as the automated analysis, you can review the data by inputting manual regions of interest. This is done using Shift and Insert shortcut keys, or by clicking this icon on the desktop. By a single click of this icon, you can draw the various regions which you're interested in capturing and retrieving specific information or data from. You can label these regions, so we'll call this specific region baseline. We'll call the second region occlusion. And we'll call the third region hyperemia. We'll just move the selected region to the baseline region and then click on the statistics icon, which will bring up the data for the baseline, the occlusion, and the hyperemia regions that we've selected. The parameters which we were recording, which include the standard power blood flow or flux, the high power blood flow or flux, the oxygenation, and the pressure. Within those parameters, we have the mean or average readings for the selected time period, the standard deviation, the standard error, the median, the minimum, maximum, time of minimum, time of maximum, total sum of readings throughout the selected region of interest, the area under the curve for the selected region of interest, the offset, slope, and any time constants which have been applied. To save this data, we go to File, Save Statistics, and then save the statistics table as a .sta file. these .sta files can be exported into Excel or any other text editing program for further analysis. So we just click save there, and now we've saved our statistics table for this particular measurement. Now we can close the statistics window and close the rest of the program. As we've now saved all the data, we can reopen the program for further data analysis at a later time. And I'd just like to thank you for watching this video. So we can now shut down.